first and foremost, I miss being in my classroom. So for now, my cookie room is going to suffice. I will let you know if you're watching this, you are either in my class or are just looking for some help on solving polynomial equations, which is what the topic is today. Either way is great. I hope that I can answer your questions. However, if you are not in my class, just be prepared. I'm going to be speaking often to my class, so I'll probably refer to things that we've done in our room, that we've done together, we've talked about before. But regardless, it should answer some questions that anyone has on this topic. So we're going to get started. We are following the book. Our textbook is the Integrated Math 3 book. It is aligned with the Common Core State Standards. It looks like this. So if you happen to have it, I mean, this is the book that we're using. If you happen to have this book, you can follow right along with us, and that would be fantastic. We're starting on page 228, and I get my notes straight from the book. My class can attest to the fact that I just wing it sometimes. So I'm hoping without their input, I can make it through a class session. So we'll see how it goes. Be nice to me. So let's look at, we're going to first start off with sum and difference of cubes. We've talked a lot about polynomials, dividing them, simplifying them. We factored quadratics a while back. We mentioned factor by grouping. All of those things are going to come into now. We're going to solve equations using all of these factoring methods. So we're going to start with just how to, first of all, factor cubic sums of cubes and differences of cubes. So the first thing to note is here are the equations. When you have two numbers that are perfect cubes added together, you can break it down. There's going to be an A term and a B term, and I'm going to refer to that a lot. The biggest difference in these two is, first of all, one's a sum, one's a difference, but you also have the different signs right here. Okay, so we have a minus AB and a plus AB. These are equations, these are, well, I guess equations, expressions that I tend to memorize. I have my students memorize. If you start with subtraction in the middle, you're going to have addition in the middle of this one. You start with addition in the middle here, we're going to have subtraction in the middle there. So just kind of memorizing those things. I know that it might be hard for some of us to memorize things, but it is the easiest way. I also let my students write at the top any equations that they need to help with their assignments. So polynomials that cannot be factored are called prime polynomials. We cannot break this up any further. So let's look at example 1. And again, I'm going straight from the textbook. So example 1 says 16x to the 4th plus 54xy to the 3rd. All right. So the first thing I notice on here, and at any time, if you want to pause the video and kind of do some thinking for yourself, go for it. But the first thing I notice here is that there's no perfect cube. I mean, there's y cubed, but 54 is not a perfect cube, 16 is not, x to the 4th. So this leads me to think I need to do something before I can solve, before I can factor, I mean. So first things first, in any case where you're asked to factor, you should get into the habit of looking for common factors. So the greatest common factor is the biggest number that goes into both of these. So what I notice here, 16 and 54, the greatest common factor between those numbers is going to be 2. You can test several numbers, 2, 4, 8, whichever, but none of those go into both 16 and 54. Also, each one of them has at least one x, so I get 2x. If I take that out of each term, I'm left with 8x to the 3rd plus 27y to the 3rd. Now I see that I have two perfect cubes. 8, the cubed root of 8 is going to be 2, and then cubed root of x is x, or x to the 3rd is x. Cubed root of 27 is 3, and the cubed root of y to the third is going to be y. So this is technically my a term. This is my b term. So when I'm looking back at the equation up here, the sum of two cubes, I'm going to rewrite this whole thing, and 2x is going to be along for the ride. We can't really do much with it anymore. I'm going to write my a plus b, or in my case, 2x plus 3y, and basically just fill in the rest of my equation. So a squared, which would be 4x squared minus 6xy plus 9y squared. All right. Looking at this, I'm going to go through. There's no more common factors. This one's kind of a mess. We can't factor that anymore. So we're done. This is our factored form of that equation. I could rewrite the whole thing like this with 2x on the outside. I could get rid of the brackets just to make it look a little cleaner. But either way, there is our fully factored form of 16x to the fourth plus 54xy to the third. Example 2, factor by grouping. So this is where we get, I think these ones are so fun, but of course I'm the math teacher, so. But we're going to get long expressions on this one, and we're going to have to break them down, and we're going to be doing exactly what it says, factor by grouping. So I'm just having a little fun with my pen here. So this example is going to be 8, you're going to bear with me on this one. 8ax plus 4bx plus 4cx. My students are like, Mrs. White, why do you do this to me? 6ay. I can hear their voices now. Plus 3by plus 3cy. Doesn't this look like so much fun? Oh, it looks like a blast. Okay, looking at it, I would love to find a common factor in every single term, but that's not going to happen here because we've got these 3's. They're not even, so we can't divide everything by 2. Some of them have x's, some of them don't. But what I notice here is this first half has a lot of common factors, and this second half has its own common factors. So I'm going to separate or group them, and I'm going to focus on the common factors in the first half of this expression. So what's common between 8 and 4 is going to be that 4. So I'm going to take out a 4 from everything. I can also take out an x from all of these terms. So I'm left with 8ax divided by 4x is going to be 2a. I took out a 4x, so I have b. Took out the 4x, so I just have c. So the first half is factored. The second half, my common factor, is going to be a positive 3 and a y. So I'm going to be left with, again, 2a plus b plus c. And some of you right now might notice, hey, there's the same thing. I'm going to get some fancy colors going up in here. All right, so if you notice, 2a plus b plus c, 2a plus b plus c is now our new common factor. So I can, again, take that out of both terms. We still have 2 terms. They're really long terms, but I can factor that out here, and I can say, all right, well, both of these are being multiplied by 2a plus b plus c, and I'm left with a 4x plus 3y. And then I'm going to scan real quick. Is there anything else I can factor out? No common factors, no perfect squares, no perfect cubes, nothing like that. So there is our answer for example 2. All right, so example 3 in the textbook, page 230, is going to combine the idea of cubes and squares. So the example, x to the 6th minus y to the 6th. Another fun one. First off, it doesn't quite look like cubes or squares, but it actually could be broken up into perfect squares. Because if you look at x to the 6th, if we take the square root of that, we're going to get x to the 3rd. You can do the same thing with the y term. So difference of perfect squares, you just do x to the 3rd plus y to the 3rd, and then x to the 3rd, and I should have changed colors, but minus y to the 3rd. Okay, so I want to focus on breaking each one of these up because now they look exactly like perfect cubes. So I have my a term is just going to be x because the cubed root of x to the 3rd is just x. And my b term is going to be y. So when I go back to the difference of perfect cubes and the sum of perfect cubes, I'm going to have this kind of thing going on. I'm going to have x plus y times x squared minus xy plus y squared plus y squared. And then I'm going to break this one up into x minus y times x squared plus xy plus y squared. That's a fun one right there. And that's all we need to do because we can't, there's nothing in common. I know it looks kind of like a mess. Doesn't help that my handwriting's kind of garbage right now, but that's how you break down the x to the 6th minus y to the 6th. All right, example 4 says refer to the beginning of the lesson, which I know that we aren't looking at right now, but from this image we can kind of gather what's going on. We have the small cube is going to be half the length of the larger cube. So we have the larger cube is 2x by 2x by 2x. The smaller cube is just x by x by x. And it says the figure, so the shaded region, is 7,000 is 7,000 cubic centimeters. What should the dimensions of the cube be? What should be the dimensions of the cube? See, I'm a math teacher. Not very good with English. That's all right. Okay, so we have a couple things here. We have the volume of the large cube, so that's 2x times 2x times 2x, or we could write it as 8x to the 3rd. And then we have the volume of the small cube, which is x to the 3rd. And then if we take the overall volume of the large one and subtract the volume of the small one, we're going to get 7,000. Okay? So something that I notice here is we have like terms. We have an x to the 3rd, x to the 3rd. 8 minus 1 is going to be that 7x to the 3rd equals 7,000. Okay? I will also tell you that the book, we typically would want to set this equal to 0 when solving polynomials. This one is kind of a weird example to go off of, so I can go show you both ways. Because there are some things I would like you guys to see rather than they're not all going to look like this. Okay, but we can continue this, just divide everything by 7. X to the 3rd equals 1,000. And if we take the cubed root of both of those, both sides of the equation, we're going to get x equals 10. So with that being said, x equals 10 here, 10 centimeters, and then the large one is 20 centimeters. So I know that this is kind of a big section, so if you would like to break it up into chunks, into days, watch parts at a time, please do that if that helps you the most. My class, you guys, I give you until Friday to turn everything in. You're going to be watching this, hopefully watching this on a Tuesday, which will give you plenty of time to keep up, and you can ask me questions. So keep that in mind as we're going on, because it does seem like a lot. But the next example, example 5, is talking about quadratic form. So in some cases, I'm just going to read this, you can rewrite a polynomial in x in the form of au squared plus bu plus c. For example, by letting u equals x squared, the expression x to the 4th plus 12x squared plus 32 can be written as x squared squared plus 12x, or 12 times x squared plus 32. Or you can write it just as you see here, u squared plus 12u plus 32. This new but equivalent expression is said to be in quadratic form. So looking at this, here's the word example and here's the number example, where they take the greatest factor here of each of these first two terms, which is going to be 2x to the third. They took that out. Sorry, oh my gosh, it's not even that late. They took that out and replaced it with a u and put it back in. So some of you guys might be able to jump to that, but I'm going to show you how I think about it and substituting and using the u, using a different variable to represent that. So here's example 5, is 150 n to the 8th plus 40 n to the 4th, and then minus 15. So the first thing I'm going to do here is I'm going to look at the first two terms. The first two terms, 150 n to the 8th and 40 n to the 4th. And I'm going to look for the greatest common factor here. My goal is to get this to look something like this, u squared plus u plus some constant. Okay. So I'm going to look at my greatest common factor here, and I see that both of these can be divided by 5. Oh my gosh, I am so sorry. I've done this in class before, so this is nothing new. Life. So I'm going to let u equal 5 n to the 4th, because that's my greatest common factor between the first two terms. All right, so now that I know I want my u to equal 5n to the 4th, I'm going to figure out what u squared is. U squared is going to represent 25n to the 8th. So what I'm going to do is I'm going to go back here, go back to my equation, or sorry, my expression, and take out a 25n to the 8th from this first term here. So 150 divided by 25 is going to be 6. So this will now be 6u squared plus, and then since u alone is 5n to the 4th, this will now be plus 8u, and then that 15 is a constant, so it's just going to stay as is. Okay, so here it looks like a quadratic now. It's 6u squared plus 8u minus 15. However, our goal is to also keep it into the variables that it was given to us. So I'm going to now replace the u's with my 5n to the 4th. So I'm going to say 6 5n to the 4th squared. I'm just taking the u and putting it in parentheses, plus 8 times 5n to the 4th minus 15. And that is the final quadratic form. Example 6, if you're watching still, thank you. Awesome. You guys are holding out strong. This is the last example. We're going to solve now. We're going to take that quadratic form idea and solve. So, start with the yawning again. I don't understand. I apologize. I promise I love math, and I'm more excited than this in the classroom. It's dead in here. There's no one to make fun of me. There's no one to tell me that I'm doing things weird. I'm sitting and not standing and dancing around. I'm not talking in funny accents. Anyway, let's just get this over with, Mrs. White. So we're going to solve 18. Oof. Okay, yes. Solve 18x to the 4th minus 21x squared plus 3 equals 0. Okay, so the first thing I'm going to do is I'm going to figure out what my u's should equal. Again, the goal is to look like this, plus constant equals 0. So what would be nice is if u is equal to our greatest common factor here. So we have between 18x to the 4th and 21x to the 2nd. You could tell it's the end of a lesson because I'm our common factor is going to be 3x squared. So if u is 3x squared, u squared is 9x to the fourth, okay? So because my first term needs to have u squared, I need to divide a 9x to the fourth out of this. So 18 divided by 9 is going to be 2. And then I'm going to have this u squared, which, well, let me rewrite that. 2u squared. I was kind of doing a mix of just jumping to the x's, but minus 21x squared divided by 3, which is 7. U plus 3 equals 0. From here, I am going to keep it as u's because this looks like something we have factored before. We were able to take our first and our last, get this magic number, right? So our magic number is 6. We want factors of 6 that add up to -7, which -6 and -1 does that. So if you have 2u squared minus 6u minus u plus 3, this is kind of, a recall moment, factor by grouping at this point. Common terms here are going to be 2u, and we're left with u minus 3. Here I'm going to take out just a negative because right now it's flip-flopped from what we want. We want a positive u and a -3. So I'm going to take out a negative, technically a -1, and u minus 3 equals 0. So I am left with 2u minus 1, u minus 3. That's going to equal 0. Now again, still recall moment. We're going to break up these two factors here. Erase this side work. We're going to break up these two factors. We're going to have two separate equations. We're going to have 2u minus 1 equals 0, and we're going to have u minus 3 also equals 0. So we have u equals, and I'm just going to kind of solve this quick, plus 1 divided by 2 is going to be 1/2. U is going to be equal to 3. I would love to call it done at this point, but we do need to go put back for x because we're solving for x and not u. But if you guys remember right here, 3x squared is what u is equal to. 3x squared, 1/2. 3x squared equals 3. So I'm going to solve for each of these. I'm going to divide this by 3x squared, and for some reason, yep, that's what I thought it was. So x is going to be equal to the square root of 1/6, plus or minus the square root of 1/6. Divide this by 3, x squared is going to be equal to 1, x is going to be equal to plus or minus 1. The only thing I would suggest to do here is to simplify this because remember it's against the law to have a radical in the denominator. So your overall answers, let me just skip to that. Your overall answers are going to be 1, -1, square root 6 over 6, and negative square root 6 over 6. Okay? I know, I kind of rushed through that last part, so let me explain what I did here. This is really square root of 1 over square root of 6. To rationalize the denominator, I need to multiply both top and bottom by square root 6, which will give me square root 6 over 6. And I have the positive and the negative version of that in our answer. We did it. We did this hefty lesson. And I am so proud of you for sticking through it. And if you didn't, and if no one watches to this point, that's fine. You'll never know how much of a weirdo I am at the end of this. But again, there's a lot to it. I understand it's hard not to be able to ask questions the second that you have them. I will be setting up lives. Okay, I sent out that survey to get things organized. I just wish you all the best. Please keep asking questions. You guys have been doing so well with that. You guys are doing a hard thing with grace, so thank you.